Welcome everybody, I'm Steve Johnson. Welcome to Digital Works TV. We have some special guests today. Jason Thompson, the president of VETS, Veterans in Engineering Technology Services, and Dr. Garrett Thurston, let me see if I have this right, the Senior Director of Services and Strategy for Dassault Systems. Dassault Systems.
Yeah, actually, and recently, I guess promoted to a Senior Tech Fellow.
Okay.
Yeah.
Senior Tech Fellow, but we're not going to talk about that.
That is a long duty title.
Well, no, I think they truncate the other stuff out of
Okay,
that.
all right.
Okay, so you are the owner of the tool. Your company is the owner
yeah,
of the tool.
Yeah. If I were the owner of the tool, I wouldn't be here. I'd be on the Riviera.
Okay, your company owns the tool that, among other things, helps modelers who work for VETS or helps students being served by Digital Works practice or learn or do modeling. Is that a fair assessment?
Yes, yeah. So there's kind of different concepts. Like a tool kind of has its own schema and services, and so we have a tool like Cameo or MSOSA, which is kind of a standalone domain tool, right, for doing system engineering. And then we have a platform, which is a digital platform, which has its authoritative source of truth and that kind of thing. And that has shared schema and services across domains. So it's kind of a complementary aspect. And the way Dassault works is they kind of acquire companies that might have tools, and then they figure out they maintain the tool, but they also figure out how to have an enterprise platform version of it too.
Yeah, the tool is one thing, right? So like the examples you brought up for Digital Works and everything, the tool is just one discipline. What we're trying to push across digital transformation is getting rid of those stovepipes. We don't want to end up with digital tool stovepipes. When he says the platform, that's a level, it's a platform with everyone's discipline tools in it, bringing all that data together.
Okay, so you're saying the platform allows people in different locations, wanting to use it in slightly different ways, can all do that?
Even different types of tools.
Different domains, right?
Okay,
So I might be doing system engineering in something like MSOSA. Somebody might be doing electrical or electronics, or be doing CAD or modeling and simulation. And so going across that, ultimately doing product line aspects, managing the way things go into production and service, in operation. So and that's the shared schema and services platform part, where the digital data is connected throughout that life cycle.
Okay, and this is one of the reasons and one of the ways that modern digital engineering is so superior to the way we used to do it, and the way we used to do it just not too long ago. Am I right?
Yeah, that's correct. It's, even today, we're still doing a very stove-type way of doing engineering where, think about when we build a house. It takes a lot of disciplines to come together to build a house. You got to share information about that one system. You can't have the electrician lay out their diagram without working with the plumber to make sure the things are going to go in the same house together. Engineering is no different. When you get a complex system, how do you make sure all those folks that are doing their different things can bring something together and make it work?
Okay, so you have a tool, and you've already said all the things it can do. Does it change with time, or do the users learn more? Which is it?
There's both, right? So on the one hand, the platform has many, many apps, and those apps are so that people can work in their particular area of expertise, and people have different sort of intelligence types. Somebody might be very algorithmic. Well, they're going to be working over here. Somebody else is very geometrically oriented. Another person is very abstract oriented. And so you can work in those different areas, and then through collaboration science be able to pull those together and be able to make sure that you're marshaling around problem spaces over time that allows you to do that. Different intelligences, not smart and stupid, but different intelligences in the way that they think about problems. A designer versus a system engineer versus an algorithmic person or a software person. It all they have to get together on complex problems. Like you think about space station, right? Space station has all sorts of things that had to be done, right, in order to get that to fly or orbit.
Okay, so this isn't just and really nice we have this. This is like important. Because things move so fast. Am I correct?
Oh, without a doubt. I mean, even if we look at from a defensive approach,
Yeah.
our adversaries and what their technology is coming up with, it's evolving faster and faster and faster. And I think if we look over the history of time, the biggest evolutions over history, that gap is starting to narrow, that they happen faster and faster. So if you're building a system, especially a defense system that takes now 10 to 15 years to get fielded, well, the concept that you came up with now is severely outdated. So you've got to develop something very complex and change it as you're developing it. So if you don't have an integrated communication network of all the thousands of people doing that, how can you get it delivered fast enough to support those warfighters that need it?
Okay, do you get a lot of feedback from people who come to your platform and use it and,
Yeah.
wow, what do they tell you?
One of the things that I heard from a CIO was that, are we working the same as we did? Absolutely not. Do some people not really like that? Absolutely. Are we more operationally resilient? Absolutely. And so, imagine that when we moved from specialists, and instead of having somebody that was doing the traceability, every person's responsible for traceability now, because they've got to do their own traceability, they've got to do their own configuration management, but you're crowdsourcing that now. And so because you're doing it at the time that you have to do it, your center of gravity is better. And so your responsiveness for what might emerge is much better than if you had, well, somebody's got to go do that, we're waiting for that. Now we've created a bottleneck, which is really unnecessary when they're working in a much more digital context.
Yeah, I think the feedback is also talked to. You asked about the evolution of the tools. You know, it's very similar to we all don't drive a Model T. Cars have gotten better over time, but also people have gotten better at driving them. The tools are the same way. The tools are naturally going to evolve as the people who use them more, but our people in the workforce that we have is actually more technologically advanced than, well, we'll just say when Garrett grew up.
Yeah.
They grew up with computers.
Yeah, so one of the things, you know, so to get back to your point is the tool evolving, and we'll call it infrastructure. So one of the challenges that folks had was they'd spend all this money with end state thinking, right? Oh, I just got to get to my end state and then I'll be good. Well, that's not the way it works now, right? The way it works now is if you're not setting up to continuously migrate so that you can exploit that functionality, you're sitting there static for 10 years before you do a big change. You can't do that. You can't afford to do that and be competitive.
Okay, so the first time you saw the tool and saw it in action, do you remember, I don't know what you were using before, can you even remember what you were using before? What was your thought? Was it just wow? I mean, what was it?
No, it was wow because, wow, I don't have to read all these thousands of pages of documentation. Because really what we're doing is taking lots of just grammatical things in paper-based documentation and putting those in a model format. You can represent a sentence with a couple model elements. I like to say modeling is very easy. It's nothing more than nouns and verbs. It's the same sentence structure. You got a noun that performs a verb, and somewhere you need to have those going together, not one without the other. So you can do that. Dramatically easier, and then the ability to connect the relationships is just super powerful. And I think that's why we see a lot of power in AI.
It's semantically rigorous, right?
Yeah.
I can write a sentence that's very poor, but when I do the model, if I do the model poor, when we go into the review, somebody's like, you got to fix that. You know, you can't, that's not semantically correct. And we have people that I work with, and they are like, fix that, you know, you've got to, and so they're always, because the modeling language is semantically rigorous. And so so the modeling is not the only piece of it, because when we do the model, we model it in a way that expresses the architecture description or the problem space. But when I come in and somebody else comes in with one of those different intelligences and they say, I need to see it like this. My concerns are about safety or cybersecurity, not about the architecture description. Then because it's object-oriented, we can recast that and put it into the shape that they need to analyze it, to understand if there's vulnerabilities.
Okay, I'm just wondering, how do you do something that's usable by a company, by an engineer, wherever, and also a tool for students? That seems like you're covering a lot of ground, and it's the same thing for all of them, isn't it?
So, you know, it's interesting. You know, what I would say one of the most powerful models that we've seen was, you know, Clive Moeller and Jack Little at the MathWorks they deployed, MATLAB, originally the public domain MATLAB, but then the commercial product from the MathWorks, MATLAB, Simulink, code generation. And so they used the student model as essentially the workforce of the future model that allowed them to exploit that to make sure that people were learning complex things and able to deploy that. And so it's the very same concept that we're doing here, right?
Yeah, I think it's very tightly knitted with the university system. I mean, that's where we go to do a lot of research and development anyways. It starts in the academic system because it's a different generation, different way of thinking. As long as we show them and give them the resources of a tool, then they can solve hard problems with it.
Okay, do you learn something from people, from the users, like from the students? I mean, because they're coming at it, I would assume, from a way that, that current engineers might not think of.
Yeah.
Do students ever say, hey, did you ever think about doing this?
Yeah, all the time. And so, we didn't grow up with the Game Boys and, well, maybe they were Game Boys, but we didn't grow up with what they have today. And so that generation is natively thinking in analytic tools and, gaming, and so they don't have the same sort of legacy biases that we might have.
Okay.
And so they're constantly innovating in gaming, and so there's a tremendous amount of value coming out of the students.
Okay, but it's not just students, it's also people who want to do advanced modeling, if they're, and that might not even be a thing, but when
It's a
you
thing.
see it, but you know what I'm saying? I mean, it's kind of cool to have a tool that can serve both things.
I think we see that a lot with, the tool was originally developed to do systems engineering in a model format. But then we see a lot of people take the tool and do things with it that aren't necessarily systems engineering. Like, well, okay, yeah, it's basically the thing is it boils down as a lot of these digital engineering tools, they're very, very powerful tools to solve hard problems.
Okay.
So it's a matter of what is your problem, and we got tools that can.
Okay, so you're sold. Does anybody ever call you and ask you about this? Hey, should we try this out? Does anybody ever do that?
I definitely get calls all the time. There's a lot of tools to choose from, and everybody loves free tools. Well, I don't, right? And there are some free tools out there, but what are their limitations? What are their strengths? And if you're in business, obviously in business, if you're not trying to think of how to do it faster, cheaper, and better than your competitor, they're going to catch you. You don't have time to go work with 30, 40 vendors to figure out what it is you need when you don't understand that. And that's why we love Digital Works, is because we're trying to provide a shop where everybody doing digital transformation can come to, and it sends you to the right places and provides you that knowledge and expertise, instead of individual companies then trying to go to every vendor, each of them themselves, to understand what it is. That's very hard to do. So, that's what the really power we see with digital.
Scalability wise too, when everybody has to go and figure that out over and over and over again, and you guys accelerate them like past go. Like, hey, it's not analysis paralysis, right? How many times have you been in, someplace and they're like, oh, we're doing a study and we're looking at it, and I'm like, we've seen it 100 times. Here's what's going to happen. It's going to come down to what's the licensing advantage one way or the other. So why don't you just figure that out? It's very interesting to see people, because they want to have legitimacy in what they do, but it's like, well, what is driving it? And if the underlying architecture is going to support your digital aspirations for the next 20 years, and you can look at another source and say, that's going to support me for 5 years, and then I've got to change, even though that's changing the whole time, I've got to change my major architecture to go from a file-based to an object-based. It totally changes the way you're going to do things.
Okay, do you have to sell people? Or do they see your tool and go, hey, this is it? Or do you have to persuade them?
Well, if I had to persuade them, I'm a bad source of persuasion, because I'm going to tell you.
But it's a business, so you have to.
I think that it's more. I'm not sure it's persuasion. I think about it as evangelism, which isn't quite the same.
I know what you're saying.
Yeah.
One thing that Garrett has built a whole model about model-based acquisition.
Yeah.
And the value of that is understanding. He's not selling a tool. He's selling a way to help you digitally transform your organization by doing it properly. That has nothing to do with the tool that his company makes and sells, but it's advocating that we've got to go digital, and here's some functions of a tool that we do have, but not saying that he's just sold on that, but the one they do produce is kind of the market norm.
And the future, that's kind of riding on these things working, right?
So, yeah, I mean, so when I'm looking at the future, I mean, you guys have heard about industry, 1.0, 2.0, 3.0, 4.0. So if we look at system engineering the same way, we're in system engineering 5.0 right now. And because of interoperability and because of the different key catalytic things that are happening in the industry, we're going to be moving from people's mindset from digital engineering into system engineering 6.0. And so we were talking about the rate of acceleration, and it's not the acceleration in those phases. We're going to be flying through the transition of that phase, right? So we're going from 5.0, and today we're sitting in 5.0. By 2028, we're going to be in 6.0, and we're not even going to remember what 5.0 was like because it's going to be flying so fast.
Yeah, anything else you want to say or add about all this?
I'll say, I mean, to just add to what Garrett just said, is this stuff is going to pick up dramatically. Right now, we're at that cusp of the early adopters of the individual disciplines using these tools. The next thing, like he said, the platform, what we call a digital thread. All this data, and if you can bring all of that together, we hear the buzzword AI all the time, right? AI is as good as the data that it can access and understand.
Yeah.
If we still at paper-based this and disconnected stovepipes, AI is no good. It's not the be-all, end-all.
It's opaque.
It's not a perfect solution. But AI can be very powerful in helping us design and develop, and even Dassault's working on some very complex new AI things, but it takes data to be connected.
An example of the shift, and hopefully this comes out simply, but who knows. But
we'll see if I understand.
Yeah, an example of the shift is that change data today is like nobody kind of thinks about exploiting it. But change data contains latent IP, because if you do a change on a system and it breaks it all up and you're like, oh, I did one change and I had a whole cascade of changes that occurred, the architecture is not enabling that change. And so if you look at the change IP, and this is what we do manually in product lines, we look at the change history and go, we could restructure this architecture to make this more facilitated, and we could have variation elements, et cetera. So if you look at change as digital IP, you can actually use change to synthesize, to drive the synthesis of the architecture. Hey, AI, I had these problems with this change. Look at that data, analyze that, do some cluster analysis on it, and then tell me, how might I reshape or recleave that architecture to have more severable elements? And then it comes back and it gives you an answer, and you go, okay, that helps, but I want it kind of like this. And instead of taking months to do the change analysis and then redo the architecture, it's minutes, right? And so it's a dramatically different pace.
That's about as exciting as it gets to have something that can change like that and be so adaptable.
Dramatically, there's a new problem, a new threat, whatever it is, and within 20 minutes you have the most optimum solution based on all the historical data we have. And now, so you literally start engineering from a positive without ever digging a technical negative debt of anything. Okay. So 20 minutes, we're ready to rock and roll and let America do what we're good at.
I think that's a key point, and that gets back to that agility, right? If you accumulate technical debt, that slows down your agility to respond to opportunities and emerging threats.
Okay, I'd call that a tool that works.
Yeah, yeah.
All right, thank you guys.
Of course.
This is great. I wish I was a little more technical oriented, but I actually understood some of that.
Well, then mission accomplished for me.
Yeah.
I can be taught.
Y'all did great. And thank you for joining us on Digital Works TV. It works.